Hello, I'm the motionless Mr. Daycock, and today I'm going to be teaching you how to differentiate using the chain rule. Now, the chain rule is used when you have a function of a function. So in this case, we have two functions going on. We've got the sine here, and we've got our cubed here. Two different functions. And this is how the chain rule works. So you need to write down, you need to ask yourself, can you write it as y equals sum f of u of x? Is that how you can write your function? If so, then we can use the chain rule. And specifically, what we can do is we can say that dy by dx is equal to dy by du multiplied by du by dx. Now, I will prove this, but for now, I want you to see is the intuition for this. See how it makes sense. Think about two fractions, a over b multiplied by b over c. Well, what does that work out to be? Well, it works out to a b over bc, but then we can just divide top and bottom by b. Those cancel out, and we get a over c. And so we get a, that's a def, we get a over c is equal to a over b multiplied by b over c. And that's exactly what's going on here if we treat these derivatives like fractions, which isn't correct. They aren't fractions, but they act like fractions in many cases. To justify it, we need to go into a bit of a further proof, but for now, hopefully you can see how this makes sense. In fact, let me use a couple of colours to make it perhaps a little bit easier to see. dy by dx is going to be equal to dy by du multiplied by du by dx. And that is our chain rule. Okay, how do we use this now? Well, what we have to do is we take our function y equals 4 sine of x cubed, and we pick our u. So we're going to say, we're going to call this x cubed in red and say u equals x cubed. So now we have y equals 4 sine, and this is very important, of u, and u equals x cubed. And now we can find those two derivatives. The two things we need to know are dy by du and du by dx. So dy by du is equal to the derivative of this one here. So that's equal to 4, derivative of sine is cosine, cosine of u. And there's no problem now because our u is just a single variable. And our du by dx, well, that's a very similar situation. Well, it's x cubed, so it's just going to be 3x squared. And now what does our rule say? Our rule says that dy by dx is just equal to these two multiplied. dy by du multiplied by du by dx. So we're going to take 4 cosine of u multiplied by 3x squared, and that will give us 12x squared cosine of u. But this isn't quite good enough because we want dy by dx, so we want it entirely in terms of x, so we need to remember what our u was, and we write down our final answer as 12x squared cosine of x cubed, and that is our dy by dx. Okay, another example. Find dy by dx when y is equal to e to the power 6 times by e to the power of sine x plus x. So we're going to pick our u. Our u is the thing, the awkward bit, the bit that's inside one function. So we're going to write this as y equals e to the u. Oh, in fact, can't forget that 6 6e to the u, and we're going to write u as equal to sine of x plus x. So we're picking our u as sine of x plus x, because that's the bit that's awkward, and then when we take it out, it's easy to differentiate. So dy by du, well, that just stays the same because it's e to the u, and our exponential function differentiates to itself. So that's very nice. And du by dx, well, sine differentiates to cosine, and x differentiates to 1. And then our final answer, dy by dx, is going to be equal to, as before, dy by du multiplied by du by dx. So in this case, dy by dx is equal to 6e to the u multiplied by cosine. Make sure you use the brackets so we don't end up losing a term or end up mismultiplying a term, which is equal to 6e to the u cosine, but we'll just leave the brackets on rather than expanding, plus 1. And we're almost done, except we need to remember that our u is sine x plus x, so this is actually equal to 6 lots of, I'm going to move the brackets to the front to make it slightly easier to view, plus 1 times by e to the sine x plus x, and we're done. That is your answer to that one. It's a complicated function, but actually not too difficult process. Okay, thank you very much. That is how you use the chain rule. Next time I'll be looking at proving the chain rule, and then going on to the product rule and quotient rule. Thank you very much for watching, and I'll see you in the next video.